Good day to everybody, and welcome to the presentation of the new version of LITESTAR 4D, which is version 7. And we think that it is really entering into a new dimension. So, the work during the past year was based on the modules that you see here, which means photo view, the photometric and spectral data manager, LISWIN, LightCalc, and web catalog. We introduce all over important enhancement to the different modules in order to access this new dimension. So, what is the new dimension? Up to now, you have been using, and you still go on using, the famous IS files or ULUM.dat files or whatsoever, which means the files that were introduced many years ago, exactly for the IS file. It was introduced back on 1986. The ULUM.dat file was introduced in 1990, and they are still used worldwide for the lighting design. But more and more new standards are coming. And those standards, like LM79, like the European EN 13032, they are more and more based on the management of new parameters, such as color, such as spectra related to the luminaires. And so the old files are no more usable because they were not thought at that time in order to manage spectra. So we developed the new program starting last year, and last year was the moment where, at the beginning of last year, we had the virus all over the world. And so at that time, we received at our laboratories over here in Italy and in Spain, we received a wide request for the measurement of UV. But at that time, it was clear that the lux meter that we have been using so far since the beginning when we opened the laboratory was not able to measure UV. So we had to add a new instrument, and using the same goniophotometer, which is not a mirror one, because the mirror one cannot be used for the measurement of UV. We started to measure UV, we started to measure spectra in the band, in the range 200 up to 400. So at that time, it was clear that we had to find a way to manage those information in a very efficient way. And not what is happening today. To get the ULUM.dat file, you apply to the intensities, you apply a factor saying that the values inside the file are no more luminous intensities, but they are radiant intensities. So whenever you use that file for the design, you have to say that at the end of the calculation, you shouldn't read lux, but you should read milliwatt per square meter. So you can imagine that this is not very nice. This is not very efficient at the end. We are trying to use something that was not thought for the design of UV, also for the design of UV. So beginning last year, we started to think how to solve the problem. And first of all, how to manage all the information through the UV, passing through the visible part of the spectrum to the infrared, so also passing through horticulture in the same way. So we realized that it was not possible to go on managing the matrices in the way we were used to. So we realized that it was the time to pass to a new type of matrix, no more based on 2D, no more based on 2 dimensions, but based on 3D dimensions. It means that the C gamma matrix is a 2D matrix, and now we have 3D matrix based on the measurement of spectra at any point of the matrix. So you can imagine that from an average of 300 values, we passed to an average of 120,000 values. So our matrix is much, much bigger than the ones we were used to. And those metrics were based on a dimension of a few Ks. Now we pass to matrices that can be some megabytes of capacity. So you can imagine that it was also a problem how to manage those huge set of information through the program. And it was a real big problem at the beginning, because when we developed the matrix the first time, and we imported the matrix at the program, it took roughly a minute to import and to integrate the matrix. Because it's clear, if we have the spectra, we can integrate the spectra, and at the end we get an integrated spectrum, but from the single spectrum at any position, we can get the information of the intensity in that position. But not only that, because we also get information about the color. So in this way, it is possible to manage also the color shift characterizing most of the luminaires. And we can say that we have a long future in front of us, because you will see that it is not only related to the measurement of those information, but it's a really new world that now is appearing in front of us. So, as I mentioned, we are now able to access new worlds, like the world of horticulture. So the calculation, for example, of what is the growth of plants. And I can tell you that we have to consider that any plant, like man, has a reaction to light through the V lambda curve. Also, any plant has a curve typical of that plant. So you can realize that it is a really huge world in front of us, because whenever you manage the spectrum, then you can conjugate the information taken from the spectrum in function of any situation. It could be a plant, so horticulture. It could be UV, but it could also be infrared. It could also be human-centric lighting. It could also be, in a very simple way, the definition of photopic versus scotopic calculations. Just a few minutes, and I show you how we can now manage it. But it is clear that starting to use more and more the spectral radiometer at our laboratories, we are now in a position to say that we move from goniophotometry to goniospectrometry, or to sphere spectrometry, because it's clear that whenever we have a set of spectra coming from a goniospectrometry and we integrate them, we get the same, roughly the same information like we can get through a sphere whenever we manage color. Because at the end, the information that we get from a sphere, it is a spectrum, and it is an integrated spectrum. I want to say that we are not in the position to say that we are now in a position to forget what was goniophotometry. We continue to measure goniophotometry, but we had new features in order to be more flexible in all the fields where a designer has to work. So, the first big change at PhotoView, our photometric and spectral data manager, was the introduction of the horticultural section. So the section dedicated to the definition of the PAR, photosynthetical active radiation parameters related to the growth of the plants. So we introduced the calculation of PPF, photosynthetical photon flux, which is corresponding to the flux we are used to. Then the yield, photosynthetical photon flux. We have the ratio in between the two. We have the red and blue ratio. We can also set up the range through the cursors we have here. And for example, we introduced a curve which is corresponding to the curve typical of corn. So the plant, the corn, that we know has a typical curve, and it was studied by Professor McCree many years ago. As I mentioned, we have basically a curve per any plant. So the focus of horticulture is to give the proper energy to the plants in order to let them grow in the best way possible. But through the development of the program and through the development of Spectra, we could also see that it was possible from the management of the color coordinates given and calculated by through the spectrum. It is also possible to define the color point. And through the color point, we decided to add an option so that you can fulfill for example, the polar diagram or any diagram proposed by the program with the color coming from the spectrum. So if it is horticulture, in this case, this is a typical curve of an horticultural luminaire. We have such a violet, red-violet color, and this is what is the color with which we fulfilled all the diagrams and graphics. But also, another big change was the introduction of the same concept for the lighting calculation. It means that right now we don't have to add any other information. In the same way you drag and drop an IS file into your lighting design program, you drag and drop now, for example, an OXL file or an IS XML file or a UNI, the Italian file, brand new file format, UNI XML file, and the calculation will be done spectrally. So it means that you will get the information straight away, also with the color, and all the area, all the room will be colored with a typical color coming from the spectrum. It means that in this way, we really save a lot of time. You have to consider that now it is a pain in the ass when you have to manage spectra, because all the manufacturers with whom we started to discuss, they are now using, for example, a ulum.file file or an IS file, and on the other hand, they have a file typical for spectrum, which is taken from the spectral radiometer. But there is, up to now, up to the new version of PhotoView, there is no mean to save all the information and pack them all together at the same file. This is the first step if you want to work in a much easier world in design and in data management. So the same approach was also introduced for the UV section for the radiometric data management. So in here, it's clear that we don't have color. You can see that here we are below 380 nanometers, so there is no color. So we have only the spectrum over here, you can see, and this is a part that it is included, it's above 380, so we can see here a little part of colored spectrum. But in any case, the spectrum coming from here, it is giving a color. So whenever you have the chance to see a luminaire for the UV, you can see that the light, the visible part of the UV, is light blue. So in this case, the polar diagram is fulfilled automatically with the related color. Over here, we have a different approach, because this is an approach typical for the UV, and so we have the different bands and the different contribution of the different bands to the total UV contribution. So we have UV spectra bands, we have the radiant flux expressed in milliwatt and expressed in average of a related one. So you can select the full spectrum, and the program will automatically show you which is the part of the UVA, UVB, and UVC. And at the end, having power, because we supply power to this UV luminaire, UV fitting, we can also calculate the so-called radiometric efficacy, which is the ratio in between the radiant flux on the power supplied to the luminaire. Another main feature that we introduced was the capability now given by the program to convert in a dynamic way the information from one field to the other. So it is possible, for example, to import an OXL file, and this file was saved into the visible light. But at that time, you can select horticulture, and automatically the program PhotoView will convert all the units into the PAR units. So it is a very dynamic way to analyze data, and I can tell you that the first reaction coming from the people who started to use the program up to now are absolutely very enthusiastic, because it is really the first time that you can have such a tool in the world. Also, at the visible field, as you know, we had already introduced in the past the spectrum management. And some features like the TM30 color analysis was introduced. The CRI section was already available. But what we did now is the introduction of a new spectral analysis in function of the bands. So it is possible, as you can see here, to split the spectrum into different bands. So the blue band, the green band, the yellow band, the orange band, and the red band. And through this table, it is possible to calculate the different contributions and to calculate the percentage of any contribution in function of a reference one. This is, for example, very useful whenever you have to measure, for example, some rooms for medicine production, because some medicines have to be produced in an atmosphere, for example, yellow colored. There are some medicines that cannot be produced in a different way. So all the factory has to be yellow. Otherwise, there are some deviations of the medicine, and you cannot use it anymore. And through this needs, you have to supply the ratios so that, for example, the blue band in those cases cannot be above a certain percentage. So this diagram at the end, this feature that we had is very useful, for example, in this case. Let's come now to LightCalc. We already introduced the concept that now we can calculate in a spectral way. So we calculate using directly the spectrum in place of using a simple intensity matrix. So you can see here, whenever we use a Unum.file file or an IS file, the information that we can get is an information related only to white light. We have no other information, and that's it. So in this case, we have a luminaire with an Excel file, and the Excel file was created from a Unum.file file. In this case, there is no color shift, and in any case, we have always the same white color. But whenever you import at the program a luminaire saved into an Excel file, for example, the calculation will be done spectrally. So in this case, the real color of light will be calculated straight away. So in this case, we use the same luminaire for this environment, this room, and for this, where we have some plants. In this case, we calculate spectrally, but in the visible field. So the values, the results that we get at the end are in luxes or are in candela per square meter. In this case, the results are based on micromoles, because we are in horticulture, and based on horticulture micromoles per second per square meter. You can see here that there is a different way to manage mode. So when you start your design, you can define whether you want to work in the visible field, in the horticultural field, in the UV field. But as you can see here, we have a huge space where we are going to introduce the different fields, like I mentioned before. So, for example, for human-centric lighting, for the scotopic vision, which is the vision that we have at night. So, in scotopic, we should calculate road lighting, and not in photopic, which is the calculation now used by the program for indoor and outdoor calculations. So you can see a huge world is in front of us. And first of all the results, as I mentioned, are straight away in the field we selected. So if we decided to design at the horticultural section, at horticultural field, all the calculations will be made based on micromoles per second per square meter. We at LightCalc, our lighting design program, we introduced some enhancements also for tunnel lighting, because we introduced new ways to calculate the luminance curve. So we introduced the European technical report 14380. We introduced the brand new standard from Italy, which is the UNI 11095. It was recently published. And we also introduced the standard from Spain, the OC 36-2015. And first of all, in order to introduce these new standard, the first one and the third one, we had to implement the definition of L20, which is the old system available before the Adrian's diagram, which is now more and more used. For example, L20 is no more used in Italy. You have to use the Adrian's diagram, even though at the end we have a curve which is different from, we have different curves, but it is, those curves are different from the ones taken from CIE 204. Also, another important enhancement that we introduced was related to the Excel import feature. It means that you can, as before, you can go on designing your tunnel through the program, but you can also work through an Excel file. What does it mean? It means that for example, in the cases that you have to change the lighting of a tunnel, which is an old tunnel based on HPS, high pressure sodium vapor luminaires, and you want to replace them, taking the same position and replace the old luminaires with the new LED ones, and this is typical of what is happening now in Italy. It is not the case to let the designers input one by one the different positions, because the company managing the tunnel, they say, we want to keep the same position, the installation position. Why? Because we don't have to change the cables, because the cables were proportioned at the beginning for HPS lamps, and the cables are more than enough for the new LED ones, LED luminaires. So they want to keep the same position, and usually over here in Italy, the company managing the tunnels, they supply you an Excel file with the different positions. So for the designers, for the manufacturers, it is much, much easier to import those files, and they just have to define which is the photometry they want to use. You can realize that in this way you can design your tunnel in a very, very fast way. And first of all, you can apply the changes using Excel, and sometimes it can be more useful to work in this way than in other ways. So, coming to LISWIN, which is our catalog data browser, that with LISTSTAR, it's a full set of modules for the management of the product catalog. We improved the feature that we called the quick check feature. What does it mean? It means that more and more designers are coming to us showing a big problem they have. You know that now we work more and more. We can say that now we are in the world only of LEDs. The conventional lamp that we were used to are no more the future. The future is LED, and this is sure. But LEDs are introducing some big problems. Some big problems for, first of all, the manufacturers, and in second hands, the designers. Why? For example, we know that LEDs are changing. For example, their fluxes, their characteristics quite frequently, and it is not the same rate like we were used with the conventional lamps. So for example, in 6, 8 a year, we may have a change in LEDs. And this is a big problem for the manufacturers because they have to keep their data updated. First point. Second point, you know that more and more the luminaires are driven through the current. So you can dim the light output using the driver. Finding a different current, you get a different flux. But how do we manage those information now? More and more the manufacturers are producing huge amounts of files. Why? Because per any current, they have to produce a single IS file. They have to produce a single ULUM.dat file. And this is at the end a huge amount of files, but you cannot characterize the complete curve. So in this aspect, we also introduced last year, and some enhancements were also included with this new version, the function managed by through the OXL file, through which you can manage the driving current, the luminaire driving current. So it means that you can have a single file and that's it. But besides that, let's go now to the designers in the market. Whenever they start to design a project, they have a project to develop, they start selecting the luminaires and they input the luminaires at the project. But then they supply the first stage of the project to the client, and maybe the client comes back after, let's say, a year and a half. But the big problem for the designers at that time is how can I be sure that data I was using at that time are still valid now? And so nobody can assure you. And all the designers are bringing us the need to have something to do with that automatically, because now they have to call the manufacturers because data through the websites are usually not always updated. So they call the factory, they call the manufacturers and ask, are there any updates for such a product? And this is time consuming. So we thought, if the manufacturer is proposing the web catalog, at that stage, at that time, we can let through the LISWIN, the designer, first of all, select the products. So simply through the web catalog, they drag and drop the information into the LISWIN, and the information is locally saved. But then whenever they want to check, they select this feature and select the manufacturer and press the button. The program will automatically show which products are updated and which ones are not updated. And in function of the selection made by the designer, let the program automatically download the updates. This can be done in few seconds. So this is another point showing that more and more our work, our development, is in function of automatizing, making the world in the highest level possible of automation. So even for the catalog creation, so this is something of interest for the manufacturers, we introduced some enhancements so that through the bridge Excel file, this is the file that we produced, including all the fields related to a luminaire, more or less are a set of 70 different information we can manage. And whenever the manufacturer inputs the information through this Excel file, to import this file and the related accessory files like images, photometries, etc., can be done in a few minutes. Let's say that to produce a catalog of 5,000 items, we can need more or less, then depends also on the capability of the computer, time more or less around 60 minutes. So in an hour, we can have a new catalog. Using Excel, it is very easy to change the information because use the features of Excel to copy and paste, for example. And importing, you can have a catalog in really few minutes and then publish it straight away to the internet and visualize it through the web catalog. Really, in very few minutes, you can prepare your own catalog. Also, the web catalog received some important new enhancements because we changed the interface, but we always kept the interface in the way that it has to be a very dynamic and flexible and fast way to manage the information. So our focus is always to come to the product information in less clicks of your mouse possible. So it means that there are some catalogs, web catalogs available from different manufacturers through the internet. They are very nice. They are very nice. We can say they are really amazing. But from the point of view of the usage of those catalogs, it is quite difficult for the designers. And the message they bring us is, I want to have a tool, I want to have a system that allows me to get to the information I need in very few seconds, because at the first time I can see nice things. But then if I have to need 7, 8 clicks to come to the information, this is time consuming. I want to come to the point in 3, maximum 4 clicks. And this is the web catalogs. First of all, also, there is another main point introduced with this new version of the web catalog, which is version 6, and a new version will come later on during the year, that all the information placed here related, for example, the polar diagrams. Let me say, if you pay a look to the different websites of the different manufacturers, there is one point, big point, which is missing. Quite always, the polar diagram is missing. So you can select, you have beautiful images, you have beautiful, sometimes videos showing the product, but the heart of the product, which is the light emission, light output, is not shown. And so it is quite difficult for the designer, who has to select the IS file, download it, open it through a program, and then he can analyze it. This is time consuming. So also for the manufacturers, these information, so the polar diagrams, like the LDT files and IS files and other information, they're not uploaded. So the manufacturer doesn't have to upload the image of any polar diagram, doesn't have to load the ulum.dat file related to the product, not even the IS file. You just have to upload the Excel file. The Excel file is let's say it is a box where you can input all the information related to the product. And those information are many more than the ones managed, for example, by the LDT file or by the IS file. And it means that from the Excel file, you can convert into anything you want, even into a datasheet, which is automatically produced by the system into 25 languages. Then, in order to improve the speed to search products, we introduced 4 different engines. So for example, you can select the products starting from the models, starting from the families through which the manufacturer organized the catalog. Then you can select the application. So I want to search a luminaire for road lighting, and so straight away only luminaires for road lighting will be shown. Then catalog. It means to input, for example, a part of the description of the product, or input the code of the product or part of it. And then search, which is a parametrical search. It is a search, for example, based on the power, based on the flux, based on the color temperature, or based on the application. So for example, you can search luminaire for stadium lighting, and the program will straight away show you only those products corresponding to the search parameters.